Or we should start.
Yeah, I think so. Will you do the honors? Will you do the honors? Yeah. Yeah, I do. The honors.
Because it's like that.
How do you feel?
Hi, good morning. This is the roll session. Welcome to everyone. We are going to start the meeting. Please be aware of the not well. We are not going to read it, but you should be aware that all the sessions are aligned with this. Please access to our meeting materials to track the meeting. This is the agenda for today. What's wrong?
This one? I don't know. I'm on another one.
Oh, well, maybe you're right.
You take it from the HTML program?
Yes, please. Well, take the link from the IETF webpage. Huh. Okay.
I mean, the name on the slide. No, that's just a second. Okay.
Okay. Thank you. This is the agenda for today. We are going to have until 12, so it's going to be funny. Some comments about the agenda?
Yeah, George. It's
Yeah.
not Georgios, it's Aris. So it's my colleague who will present the drafts.
Okay.
Okay?
Yeah.
Thank you.
Okay, Aris. Okay, we have updated the milestone list to more realistic dates. So we are going to try to keep this up to the date. Yeah, I sent the link that was provided by the IETF.
Congratulations. I didn't have any problem.
Okay. Okay, this is the status of active internet draft. Some of the drafts are in pause because we are waiting for people to be interested on that and work on that, like young models. Yeah. And some of them are going to be present today. Okay, we are going to have a presentation as well related with the 60s that Michael is going to present enrollment priority that is used in 60s. And okay, we sent an email about the IPRs that we have in the current documents. So if you have some comments on that, please send to the mailing list. And now, Aris.
I wanted to make a few comments. It's the first role in our chairmanship which takes so long. So it's a bit of an experiment, and I hope it will turn out correctly. But we have lots of new subjects, and I think they are worthwhile the discussion, especially the discussion about how to use beer within role and how we're going to forward that. So we all think that needs some time. On the other hand, we have a few drafts which are already some time there, and we really want to conclude them this year. So I would be so that we can take on all this new work. Yep.
Hi, so I'm Aris. Is this okay? We have started this draft relating to load balancing. We have created an objective function that is traffic aware.
What is the microphone?
Yeah. Really? Like this?
You can take it.
Oh.
You can take it off.
Okay. Very low tolerance. Oh, okay. Yeah. Okay. Yeah, I feel like I'm meeting it anyway. Yes. Okay. So There have been some existing standardization efforts for objective functions. There's the two well-known, which are standards, and CASEM has proposed load-balanced objective function. The problem with using the standard objective functions, as described by the draft in CASEM as well, relates to networks becoming unbalanced when you use them. So some nodes will get overloaded when you use those objective functions. That will typically lead to lower network and node life. And as a result, we will have higher packet losses due to queuing probably, and higher packet delay. Well, this is very... So I have an example here of one network in which all nodes send data with the same packet rate. And as you can see, it might be unbalanced. In this case, a balanced version would be like this, where it's half and half. Now, the objective function proposed by CASEM will solve this problem because it uses the child node count to balance the network. However, if the nodes don't all transfer data with the same rate, the result will not be balanced. So in this case, this node doesn't actually send data with the same rate as the other ones. So in order to balance it, you will actually need to make it like this. So the child node count won't be the same. So this is what we are trying to accomplish. So we created a new metric. We called it packet transmission rate. And in our case, we use the packet transmission rate for each node. So it's a local information. But Derek, I don't recognize him, but he proposed that we could also use a cumulative version of this, where the packet transmission rate would be the cumulative thing for all the subtree. We also use a predefined time unit for the period which we use to transfer the packet transfer rate, but we could also introduce we measure packets sent per time unit, and in a TSH context, maybe it doesn't matter, but if you want to be a bit more general, maybe you need to measure octets per time unit. In any case, our objective function basically selects the preferred parent by the parent which has the lowest PTR. So this is an example of a DIO which contains the DAG-MC, and within the DAG metric container data, you would have something like this, a new routing metric container type, which needs to be assigned, and just a 2-octet packet transmission rate. So this is the current state. We have some very, very preliminary results. We have a network here. We used Contiki to simulate it. And we have, you can't really see it maybe in this diagram, but basically the network is heavily lopsided toward this part. So nodes 2 and 8 send data much faster than the non-bold ones. So this, if you load balance the whole network by either ripple, it won't work well, but even with child node count, this node will typically have more children, although it should be more, some of these heavy nodes should be assigned to 4 and the rest to 5, so it's a bit skewed. So we did some experiments with that, and we compared how the traffic will be balanced with Mr. Hoff and load balancing. So we have some improvements in PDR. The load balancing metric already gives better results. Ours gives a bit better, and Mr. Hoff tends to slightly do worse due to the load balancing issue. We also count parent changes, so you will see there's a lot of variability here. That's a side effect of the very preliminary results.
But in this case as well, our objective function is a bit more stable and leads to fewer parent changes. And we also count how many DIOs were sent. The idea here as well is that the number of DIOs sent is an indication of how stable the network is. So in this case, we do a bit better as well. And we have some issues already. So after discussing the whole idea, we need to discuss how general we want our solution to be. So a lot of things at the moment are predefined. So you hard code them to a constant. One idea would be to either keep it as it is, or also keep a few bits in the metric to send also the data unit. So packets or octets or whatever. Another issue is the time unit, and that might also be a good idea to send it, so you can express a wider range of values for the time period. So are you talking about packets per hour, packets per minute, packets per day, whatever? And one other issue is that we assume that all nodes have the same forwarding capacity, so that might not be very reasonable. So we could normalize the PTR to a given capacity, or we could send the max capacity as another field as well. So obviously this has some network overhead as well. And we also assume that all nodes consume energy with the same rate. So you already have the energy metric container, which you count energy remaining until the end of the battery, but I haven't seen something that actually counts the rate of consumption. So you can deduce that from the, to some extent, how much energy is remaining, but it might be more accurate to use something like this. Finally, at the moment, the packet transmission rate, again, it's derived from what the nodes, what a node is forwarding in terms of traffic. And it might be a good idea to, because at the end, what you care about is the whole path to the route. So maybe that would be more interesting. So we'll do a cumulative version of this metric. So at this point, we had this discussion yesterday. Some of these metrics might be interesting to add them to the EB information element, so that nodes are better able to do the whole join process when selecting a network. Obviously, it can be rolled into one of the priority values we discussed yesterday instead of being a separate thing. And we were wondering whether there might be things we might be missing. And I would like to thank Derek for the very helpful comments. I think that's it. Yeah.
Thank you. Comments?
Sorry. So I think according to our discussions yesterday that we had with Pascal, with Mike and all 60 guys, I think maybe this is not interesting to be part of the EB package for the moment, since it is layer 3 information. I don't know what you think, guys.
Rahul Jadhav. So I definitely think this work is interesting. I just want to inform that we have done some similar work, and I'll be able to get some data about that.
Okay, maybe you should discuss and see if we can find some common ground.
Great.
Okay.
So it definitely has an impact on the network lifetime, is what our observations are. Having said that, we have not experimented with 6-dish. We had experimented with single channel mode of operation. With yeah.
Okay, great. Thanks.
Michael Richardson, can you go back to your diagram?
Which one?
The one with the 7 and 8?
Sorry?
The one with nodes 7 and 8 and 2 or something? Yeah, that one.
Yeah.
So as I understand it, it would be desirable for node 8 to pick 5 as its parent, because node 2 has 4 as its parent.
Yeah, that's the idea. So you would split them, these two, let's say, with 4, or maybe 2, 3, and 7 with 4, and then 8 and the rest with 5, something like that.
So that's what I was actually interested in, was node 7. If you want to also try to balance the children, then it seems that you very much want to make sure that 7 connects to node 4, such that node 5 has the capacity to accommodate node 8. And I'm wondering, how do you kick 7 over that way? Because it's not sending traffic really, but it is occupying a.
Oh no, so that's my mistake. All these nodes are actually sending data. I went through the details of the simulation. All of them are sending data.
8 and 2 are sending a lot of data.
Yeah. So these are sending 1 packet per second, and the rest are sending one packet per I, where I is the ID'd second. So
Sure.
1 per 7, 1 per 6, etc.
Sure. Okay. But what I'm trying to understand is I can see how you can how 2 and 8, need to make intelligent choices about there. I'm trying to understand how in your algorithm does node 7, which is not a high sender, how is it discouraged from connecting to 5 such that number 5 has the capacity, the child, not the bandwidth capacity.
Okay, yeah.
The child slot capacity. Because if 5 was overloaded in terms of children, then it would be unable to accept 8. But 7 could go the other way, right? So they need to.
So this goes into the details of the simulation. If I remember correctly, the default settings for the simulation allows up to 8 neighbors.
Okay.
So I would guess that wouldn't necessarily be an issue in this example, but in general, yes, you're sure.
So it might be good to do some experiments where you have enough nodes such that you actually will overload the child capacity, and then see if you are still able to migrate or partition your network, given that you have children that, like 12, has no choice. It has to be. The other ones have no choice. They have to be there. But 7 is critically, it has a choice.
Yes.
Right?
So these nodes are basically here just to add some traffic to 5, of course. But you're right. Yeah. We should.
Rahul Jadhav. So one more thing in this context, just because so the objective function here takes into consideration only the packet transmission rate, but in our opinion, it has to be clubbed with some other metrics as well, because packet transmission rate alone, if you end up using in that objective function.
You're right. So normally what we would do is use some other metric as well, like ETX or something else, and use the packet transmission as a secondary metric.
Yeah, that's when actually things become tricky.
So there are some problems with that. In Contiki specifically, it doesn't allow multiple metric containers, so that was a bit tricky. But yeah, we have that in mind as well.
Another thing you have already mentioned is using cumulative metric, which is actually very key. It's an important thing to be considered for this experiment.
Yeah. Thank you.
Yes.
So is it part of this? I'm Charlie Perkins from Futureway Huawei. Is it part of the simulation parameters that all the nodes have essentially constant transmission rate?
Okay, so the period is constant but different between the nodes.
Yeah, they're different, but they're all constant.
Yeah.
So if you had, is that a pretty widely applicable thing? I would think that a lot of the nodes would have varying flows, and then you might be subject to some sort of oscillation.
So you're talking about bursty traffic, right? Yeah, you might have that. That's a problem with all the objective functions. Whenever you have like some abrupt changes, you need to be able to adapt, and depending on the period, how quickly how often you get the DIOs, the update might take some change, and you might have some problems. Yeah, for sure.
It might be interesting to see how stable the solution is given various, let's say, parameters for variations.
Yeah.
Thank you.
Yeah. So for sure, we are working on it, and we're going to do some more extensive experiments for that. Thanks.
Thank you, Aris. Who has read the draft? Who is willing to review the draft? Great, thank you.
Thank you.
Michael. Okay, next. You are next as well. Yeah. Aris presenting the next.
Okay, so this draft We had presented it again in Singapore. We have some changes. I'll probably go over them a bit quickly. So we are creating a new TLV in the NSA in the node state and attribute object within the metric container. This is used basically for enabling PRE, packet replication and elimination. So since the last version, we did some editorial changes. We improved some of the diagrams and some wording. We specified how some of the DAG MC fields should be used. And we also created some Wireshark dissectors for this field. So the idea here is that we are trying to, as much as possible, achieve some determinism to get some reliable communication and some low jitter performance as part of that. So the idea is to use packet replication and elimination. So you replicate the packets to multiple parents. You make sure that whenever they arrive at a common node, they get eliminated so you don't get a storm of packets. And you also use promiscuous overhearing to increase the number of packets received. So it's more extensively dispersed. So in this draft, we're basically going to work on the alternative parent selection. So in order to do the replication, you need to choose where to replicate the packet to. And this work relates to the parent selection, to whom to replicate to. So we need to extend the DIO messages with some information to allow child nodes to select an alternative parent as best as possible for our purposes. During that, for that parent selection, our draft enables it to function at all. And specifically, the idea is to allow selecting an alternative parent which has a common ancestor with the child parent. So in this diagram, the idea is to be able to select B, which has a common ancestor with A. So B needs to be selected for that purpose. I will show a very quick example afterwards. So we have an example again of the DIO packet with the DAG metric container, and in it we have the NSA object, and within the NSA object we have a request for a new TLV, an optional TLV, which describes the information, which has information used for PRE. And this information is basically a number of addresses, of IPv6 addresses for the parents of a node now. Okay. Some of the new stuff is how we use the MC fields. It was requested that we fully specify them. So basically, we defined that it's used as a constraint. We had allowed it to be unspecified before. Yeah, that's mainly the only thing that we needed to define, that this is specifically a constraint and not a metric. The other fields are not really affected. And we also implemented the Wireshark dissector for it, so to make sure that we are correctly creating the fields. And so here is a quick example of how this would work. If you have this network and you have, this is the preferred parent of S and D is the preferred parent of A, and this is the parent set of S and this is the parent set of A. And finally, you have some intersection here. This is a parent set of B. You want to select the the B node as the alternative parent for S, since there is an intersection here. So since D is in the parent set of both A and B, you select B as an alternative parent. The idea here is that whenever you do the packet replication, the replicated packets won't veer off too much from the original path. And the reason for that is to keep jitter and the latency in control. Now, one issue we have is that unfortunately sending all that data is pretty heavyweight, like 16 bytes per IPv6 address. One thing that we have done is to remove half of that to somewhat compress it, but again, that's not ideal. And we also have some ideas. We are thinking about using the same information, not for keeping the route of the replicas close to the original path, but intentionally moving away from the original path to get some extra diversity, both for just the preferred parent, so even without alternative parents, and also for multipath when we want to do replication. So this is it. I don't know if this is interesting and if there's some interest to continue this work. I had hoped to present some extra experiments, but well.
Michael Richardson, to compress your V6 addresses, code that's probably already present would be in the 6low RH header, which basically has a list of addresses, and since they're similar, it does a very good job of compressing them into maybe 1 or 2 bytes each.
That would be ideal.
And the code's already probably present on most systems. So
I'll keep that in mind. I'll take a look. Thanks.
Carsten Bormann, I have a non-technical comment. You have a draft with an object that is called NSA.
Yes,
and
unfortunately, the wording was.
That is called PNS. And
I didn't realize that just
maybe
until now.
Think about the
Yeah.
abbreviations.
I was always saying PNS, but it never occurred to me.
Peter van der Stok, I'm a bit curious. I mean, we just heard you about parent selection, and there was an algorithm, and there are also other people who have done drafts about parent selection. How do you think this proposal will actually coexist with those parent selection drafts?
Okay, so that's obviously an issue. Depending on what you want to achieve, I don't know if you can necessarily do both at the same time. So what we use at the moment is use a normal metric like ETX or whatever, and use our constraint just to constrain the alternative parent. So it can work with other metrics pretty okay. That's not a problem in itself. Yeah, well, I hope to present some result as well. We have it almost fully implemented. I hope that I will finish that pretty soon. Yeah.
Pascal Hubert. The objective functions that usually we present at the IETF are very simple, like use one metric. But we expose a lot more metrics, and now we expose more and more stuff. And a real-world objective function may be more intelligent than that. An objective function can be a piece of logic. It's meant to be a piece of logic which ties a number of metrics together. And the way it's tied together may be, first you look at this because that's my most important concerns, and the other things may be tiebreakers or something. In this case, you really want to build 2 non-congruent paths with the capability to do packet replication and elimination in the middle of your network, because those networks are so lossy and you really want your data to go through in a definite time. So that's your priority. Now, if you can do that, and if you see multiple parents which would fit, then all of a sudden your OF may be taking more ideas from some of those component OFs that we have, use the BS-based ETX, or use the load balancing that we just saw. I mean, that's how it's really bound together. It's the fact that your objective function will not be one of those simple OFs that the IETF has produced, but one which really does what you want. So if you have an industrial consortium which really cares about deterministic properties or closer to deterministic properties in this network, it will want this. And it will try to do some traffic balancing if that's possible. If I have multiple solutions, then as a secondary thing, I will look at the load, or I will look at the number of children, or whatever else. Right. So that's how it's bound together.
Would be nice. Would be nice if your draft could show that a bit also.
Yeah, we're actively working on it.
Who has read the draft? Again, who is willing to review it? And this work is important for 60s, right?
Well, parts of it are. So this draft specifically, no, but there are parts like support for overhearing, which we actually need to create a new cell type in the schedule for 60 as well. Yeah.
Okay, thank you.
Pascal again. Well, 60 does not need that, right? But a solution that would really benefit from that would also really benefit from 60. To make those two work really well together, you need a 60 infrastructure so you can schedule stuff, and you need this. Because overhearing really means that you need to know when and where a certain talker will talk. So A will talk to B, but C will be listening. And so if you have some form of schedule which allows people to know when those transmissions occur along this shape that we have just formed, then that's when you get the most benefit of it. So 60 will not say we need that, not at all. But a solution which needs that will also need 60.
Okay. Thank you. Okay. Who is willing to review it? Sorry, again. Okay.
Thank you.
Thank you.
Looking forward to the next version then. Okay.
Next one, Raul. Where? Ah.
Hello, everyone. I'm Rahul Jadhav from Huawei Technologies. So I'm going to present Ripple observations. So basically, these are just observations, no solutions here. These are some of the issues that we found during our solutions analysis, design, deployment, implementation, not deployment, pilot actually. So we ended up having some sort of solutions to some of these problems, but we definitely believe that those solutions are not optimal, definitely not best in all the cases. And we wanted to bring these problems to working group to check whether these make sense and if we are not missing a major point here. So that is what we wanted to check here. So our deployment, our pilot was primarily towards smart meter networks, where we have 1,000 node cardinality with 16 hops, which is quite big. And we have storing as well as non-storing mode of operations involved. Having said that, most of the problems that are enlisted here are related to storing mode of operations. But we definitely believe that some of these problems can be solved in a better way. Okay, so first problem, this is one of the major problems that we have faced is how to handle the DTSN increment. This is non-trivial, especially in storing mode. Actually, in non-storing mode of operation, this is pretty easy to take care of. In storing mode, how do you increment the DTSN? So the decisions that you make directly impact the downstream route availability. It directly impacts the control traffic overhead for the DAO. And overall, it has a major implications on overall number of parent switchings that are present in the network. And we think that, this has to be handled, and not necessarily by, I don't know, the suggestions could be completely different, could be completely. So one thing I wanted to check out if how beer or some other proposals, how those proposals can impact these problems. So that is still under consideration, that we have not read those drafts. We have not still considered or understood those drafts clearly to check whether those have some implications on this problems. So depending upon, so this is the first implementer's dilemma that we had. So in which case should the DTSN be incremented? So DTSN is a number which is, it's a sequence number which is part of the DIO message, which essentially tells the other child nodes in what, whether it should send a DAO message or not. Now there are two problems here. Now there is currently no way for the target node to know whether the DAO has actually reached the border router. The end-to-end path has been established. So it needs so the current network, the current mechanism has to have enough redundancy, DAO redundancy, so as to make sure that the DAO actually reaches the border router. And after that, it should ideally start the application traffic. It is very important because if you end up starting the application traffic before the routes are established end to end, then you end up clogging the network, you end up queuing, the acts are not going to come back, and you don't want to ideally start your application traffic during this time. So essentially, so should the DTSN be incremented with every DIO trickle timer? Now, I know for sure that at least the old implementation of Contiki incremented the DTSN in every trickle timer timeout, which is bad. But then there is no option, I feel, because the moment you have a higher number of the number of hops increase in case of storing mode of operation, you have to depend upon this particular incrementing of DTSN so that you ensure that your DAO actually reaches with some confidence to the border router. Now, if you don't increment DTSN in DIO trickle timer, then your DAO redundancy is too low. You have a high probability of DAO not reaching the border router. And yeah, of course, with the increase in the number of hops, the probability of DAO success drops sharply. So this is something that we had seen happening in our networks. And what we had seen is actually the network convergence time, 90% of the nodes gets joined, but the remaining 10% of the nodes, they do not join for a very long time. And it's very difficult for us to actually ascertain whether, so we found that this is one of the primary reasons. Second, in case of parent switch, should the node increment its DTSN? Well, it looks natural to increment the DTSN because you want the subchilds, not only the subchilds, but the sub-DODAG rooted at that particular parent to update its route. But the moment you do that, you have a lot of DAO traffic. Because the whole sub-DODAG, so you go on incrementing the DTSN, not only you, but your subchilds have to increment the DTSN. The complete sub-DODAG has to go into the, it floods the network for that particular sub-DODAG. So that is what we have seen. And so is there any better way to operate this? Storing mode is the mode of operation that is considered here. In non-storing mode of operation, again, this is not a problem. Now, this again is one important point, and it has, so DAO-ACK, this has some relevance to the previous point discussed, the DTSN increment. If we end up handling the DAO-ACK properly, then it will solve a good number of issues. That is what my opinion is. There had been discussion on the mailing list in 2015 regarding this, and there are implementations. For example, with the current Ripple spec, there are multiple interpretations possible. Whether DAO-ACK should be sent hop by hop or it should be sent end to end. And there is no way that this, once currently Riot implements hop by hop acknowledgement, the older version of Contiki implemented hop by hop acknowledgement, but recently Contiki found that they need end to end acknowledgement mechanism, because the primary reason is the target node, without this mechanism, the target node won't be aware that it has reached the border router. So how should an implementer interpret this particular scheme in the Ripple specification? There are pros and cons for each of this mechanism. Hop by hop acknowledgement is actually pretty easy to implement. There is no state involved. In case of end-to-end acknowledgement, either there is some sort of state involved in the routing table, or there is some sort of overhead involved in the network control, network messaging. So it has its own pros and cons. We eventually ended up implementing this end-to-end acknowledgement, but in a different way. Without that, we couldn't get our convergence time in any good shape. So the other problem here is, how do we handle aggregated targets in case of DAO-ACK? So DAO-ACK is for a DAO message and not for individual targets. And a DAO message can actually contain multiple targets. So how do you acknowledgement? How do you acknowledge a particular DAO which has multiple targets and one subset of those targets fail? This is a problem. Their Ripple specification says that acknowledgement cannot carry any new options, not new options, any existing options. So there's pretty much no scope for improvising here, unless and until you have a non-standard variance of implementation. So another problem is Ripple is not clear on how to handle aggregated targets. It certainly allows it. There is a definite wording in the specification which allows aggregated target, but it does not have failure handling for it. This has been discussed on the mailing list in 2015 as well, and I feel this is important to be handled. If you see the two most popular implementation, Riot and Contiki, does it in a different way. Today, it is impossible to get any sort of interoperability possible between these two implementations at multiple hops. What we have seen is Riot sends aggregated targets, Contiki doesn't handle it, the network never gets formed. So the way I've experimented it with is I have a border router and a few of the nodes which are Contiki and but this will have a problem only at multiple hops. If you have a smaller network, you're just doing an interop at a very small size on a table with all the nodes speaking to border router directly, you're not going to have any problems. The moment you try to scale, try to achieve performance at a bigger scale, that's when all these problems will start creeping in. So DAO-ACK is important. I've already talked about it, because it is important to know when the end-to-end path is established. It is important for the application to know when it should start its traffic. In case of hop by hop, the DAO-ACK can fail. Hop by hop acknowledgement is actually not much useful in my opinion, because you have link layer acknowledgement as well. So in most of the cases, most of the implementation disable it by default. So I don't know if anyone uses hop by hop acknowledgement mechanism to achieve anything specific right now. So there is one more alternate behavior that we have implemented. Basically what we have done is the DAO goes like this and the border router eventually sends, or the root eventually sends an acknowledgement directly using a global using the global IP, because the downstream path is already established. So this way you can have least overhead in terms of control traffic. You don't have to have any additional routing state on 6LRs. But the problem here is you can't handle aggregated acts. So there is still a downside to this particular solution. But we eventually ended up implementing this solution, and we got a good improvement in the convergence time. This is the mailing list, which was actually discussed in a more substantial way. There are a lot of discussion that has happened already. The next point I'm going to discuss, I'm not sure, I would really like to have some feedback here, and this is something that we have faced. So in case of storing mode of operation, Ripple has some state information to be maintained across node reboots. In case of IoT devices, the flash endurance is a big problem. If you end up having your network protocol flashing something to the persistent storage every now and then, it's not acceptable. At least this is what our solutions requirement team told us. It's not acceptable. So you have to handle it in some other way. So I'm not sure if anyone has handled this particular problem. Current implementations, open source implementations don't handle it. They expect that there is some persistent storage, but they don't handle it by itself. And we feel, again, this is important. Again, this is more impacting, especially in case of storing mode of operation.
Michael Richardson, did they say, so do they say that you can't write anything to the flash relating to the network, or did they say that there's some upper limit?
Yeah, so there is an upper limit, actually. That's a good question. Thank you, Michael. So if you see the draft, I've given some good numbers in there. I've actually put in the numbers. So,
okay.
So if you end up incrementing DTSN even 5 times a day, it's a problem.
Okay, 5 times a day is a problem. Okay, 1 time a day?
1 time a day should be okay, but still what happens is, now your network lifetime is not dependent upon your battery, but the flash endurance.
Of course, yes. But of course, now you still have network battery to tell the system that you're dying because your flash is running out, at least, which is better than the other way, right?
Yeah.
But the reason I'm asking is because there's other things like ASNs in 6-stitch and other stuff and network keys that you do want to write to, but you don't need to write even daily to the system. So, but there are some other things that the network stack needs to keep track of, I think. So that's why I wanted to know if there was some threshold that is a pain for them. And then, because your other slides were how often do we increment the DTSN? Well, clearly the answer is not more than once a day.
Yeah.
Right?
These are sort of.
Okay. I had some other questions, but I wanted to wait to the end, I think, because you seem to have a lot of issues.
Sure. So just to mention something in this context, we have done some real experiments, and the number is substantially bigger than 5 per day in storing mode of operation. And that too with a modest sized network, not a very open network.
Carsten Moment, what level of load leveling are you using when you say 5 per day is too much?
Sorry. So you're talking about write amplification, where you change the location of the flash so that it gets leveled across multiple this thing. So I have put some numbers in the draft. Please check, if those make sense.
Okay.
I really want those to be reviewed, and I would really. So I've put some specific information considering the write amplification, considering the node endurance level, considering MLC TLC flashes, and then provided some data there. So most of the IoT devices implements CC2538 to CC2650, for example, implement some cheaper flashes, and it's a big problem with endurance there. 6LRs in particularly are more impacted. Border router, we don't care mostly because we assume that it has some sort of other mechanisms to handle it. Okay, so this is again a hot topic. It's already been handled by I think other works in progress, and this is definitely impacting the overall solution implementation for us. Basically, handling resource availability in terms of neighbor cache table and routing table. How do you handle what happens when the neighbor cache entry goes full? There is no signaling currently. I think part of the work has been done in the enrollment, as part of the enrollment draft. But there are certain scenarios which I still feel may not be able, the draft might not be still able to handle it. For example, in case of this, let's say, for example, there are 4 routing table entries on N1 and N2. Eventually, there is only a single X6LR here. So, or rather 3 routing table entries. So how do you signal it? So N3 has only one preferred parent. So either all these 4 entries will go through this N1 or N2, and both of them have routing tables. So how is this going to be handled So there are some scenarios which are really tricky, especially when in context to handling resource availability. And this has been a major problem for us. This directly impacts the network convergence time. This directly impacts the packet delivery rate for us. And we have an implementation which tried to solve this issue, and we have not ended up anywhere as of now. But we have a lot of observations, and I feel if there is some, if other people have some other alternate solutions, we would definitely like to understand. And we would definitely implement if someone else has a solution towards this. All right, that's all. Thank you. Questions, please.
Michael Richardson again. This is wonderful work. I really would like to adopt this. Is clearly there's a bunch of updates. Your points about DO, ACK, hop by hop versus end to end. I implemented end to end from just thinking about the problem. I said, well, it has to be end to end, or there's no point. But it hadn't occurred to me that the spec was ambiguous about that. I think I just assumed that was the case. So clearly there's some bugs in the spec, and I think you've identified those. And I think that the places where my suggestion is that I haven't looked at your document, I'm sorry, but I think you should split it into ones that are clearly there is a problem here. It doesn't matter whether you recommend end-to-end or hop-by-hop ACK, so long as the document outlines those 2 things, that there's an ambiguity as to what it is, and then the working group can adopt the document and make a decision. In fact, I think we should adopt the document with, A or B, and as a working group document, and then we should make a decision as the working group as to which one we're actually going to pick. So a bunch of those things. DTSN increment. I think that's a bug in the spec. I don't know what the answer is, but it's clearly a bug in the spec. Okay. So I think those are updates to 6550, and I think that would be a really good document to do, and I think it should be in some sense non-controversial, right? And then you should have a second document for issues like this one, which honestly we've known about in some sense from the very beginning. We don't have an answer for. I think ultimately it kills storing mode.
Yeah.
Okay.
Exactly.
I think ultimately that's what happens, and so things like DAO protection and stuff like that gives us back a lot of the features of storing mode, doing it a different way. But I don't know how to solve the problem either. And it might just be that in the end that you have a document which updates 6550, obsoleting storing mode yeah. As a result of this kind of problem, or saying if you're going to implement it, be aware of these issues to which we have no solution. And so think about something else. So that may be a very small thing. So I think that's the right answer to me. That's where to go forward. But the bugs, I would like to see that just, let's do the document, let's adopt it, let's get it published by the end of the summer, okay? Because I think that's like I think it should be non-controversial once we have the two questions in front of us at the next meeting. You know, A or B, let's hum A or B, which one do you want? I think it would be very conclusive once the details are in front of everyone. They'll go, well, obviously it's B, or obviously it's A. And I think that's just the way to go. So thank you very much for this work.
Thank you.
Well, I agree with Michael about thanking you so much for the work. I don't agree with much else.
Okay, that's great. That's actually great. I would like to understand that.
Okay, so I can give you some history on some of those things,
No.
and I agree on the fact that the spec is not complete and how you use those things. And part of the reasons is probably people didn't necessarily agree on how to use them when we wrote the spec. So we ended up leaving it open so the next generation would decide, which is what's happening now. So I'm very, very, very happy to see this. So I love your draft as a prime statement. I would not rush to the solution because the reasons why those primes are still there is because we could not solve them the first time. So don't rush and publish something in 2 months. That's where I disagree with Michael, because it's not that easy. The DAWAC was meant to replace, because you're thinking about radios, right? Ripple is a routing protocol. We run it on wires and on very high-speed networks, actually. So DAWAC is really when you don't have a layer to hack. The initial design was not end-to-end. I mean, if we want to design an end-to-end DAWAC, let's do it. We don't even have to call it DAWAC. We can call it the way we want, and we don't have to stick to the DAWAC format. The DAWAC is really there when you can't leverage a lower layer thing for doing it. And Ripple has a number of things like that where you say, okay, if you have a lower layer thing, which will do it, you're okay. The idea was, if you have a DAO information, you need to pass it to your parent. And if it doesn't work, then you need an acknowledgement and you retry. And if it doesn't work, then you have an acknowledgement, you retry. At some point, you need to pass it to dev. And yes, it might, we have to see the consequences, but we hoped it would work after, ultimately retrying to dev, it would end up working. We have to talk about what happens when it does not. Just discovering that it did not doesn't help a lot because you don't know along the chain what's broken. So we have to figure out a solution. It will take a little bit more than a second to get there. But yes, I understand the end-to-end route because we are, the initial design is just local acknowledgement. It's not end-to-end. We want something to solve the end-to-end. Let's work on it. It's not there.
Okay, all right.
The DTSN was initially something that you would trigger either if you find a discrepancy in what you see, like, those flags in the packets which tell you there is something wrong there. I just want to assert that I have my knowledge of my children is what it is. And the idea was either you ask just your first hop children or you go, as you said, down through the DODAG. It could just be a one-hop refresh. I think the option is still there. Initially, that was the option. So I just don't remember what ended up in the spec. We made so many revise. But in my mind, it was either poll your first hop children or poll everybody. One design behind it was to rebuild the DODAG without reforming it. If you change the version number, you will reform the DODAG. The shape of the topology will be changed, right? Because people will do parent selection. Now, imagine that you do a DTSN and it's recursive. You skip the same DODAG, you just repaint it, right? By painting, I mean re-put the addresses where they are on the DODAG. So that was the difference between the DTSN and the version. Version rebuilds everything. DTSN just repaints the existing structure. So that's what, I mean, use it when you want, but that was the design. And the when you want now is what is not described enough. And that's where your prime statement is so good. One thing was I find the discrepancy looking at the data traffic. I'm getting a packet from somebody and I don't know that somebody. Okay, interesting. Do I know all my children? Right, that's one reason. Another reason is, I think these guys, well, the packet going up when you think it should be going down, all those things. So there is something wrong. I may just repaint my graph to see who's behind me. So these are the sorts of reasons. Also, another one would be I want to reparent. I lost all my possible parents, and I would like to explore who's behind me, so I avoid them and I try to jump to somebody else who's not behind me. I just want to reassert who is behind me. I just reassert that this guy is not behind me. Let me jump to it and take the risk. We can stretch. We can actually go down a little bit. So that's one way to make sure to hopefully don't. But that's not for sure. But that helps. What I wanted it for personally was the capability to rebuild the network, I would say intelligently, by having a timer which is longer at each, getting shorter at each hop as you progress the DTSN, the new DTSN, so that the children would advertise and then their parents and then their parents and then their parents each time after a timer, you see. And so enable like the repainting like a wave. We never actually standardized that. But that was one way. I wanted that not only to repaint the DAG without changing it, but also to do it like smoothly, like a counter wave, away from the bottom to the top. So that's what it's for. Now, can we use it? Is it usable, etc.? I'm just telling you what it's for.
Yeah.
Okay. And then again, I agree with everything about the prime statement, things being unclear. I'm just telling you what the tools are for. The ACK was local, one hop.
Yeah.
If we're missing something more, let's design it.
Yes.
Don't call it a DAC because that's not what it is.
Yeah. Thank you. A lot of points there. Yeah.
Michael Richardson again. Pascal, that was wonderful. I'm so glad it's on tape. I think that you're in violent agreement with me, actually. The point is that if there's inclarity, and you just clarified about 4 things, okay, that clearly many of us were unclear about, okay, so clearly 6550 didn't say it clearly enough. So that's what I'm saying. All those things you just clarified, I would like that in a low-hanging fruit update document, okay? And if it turns out that as you said, we need an end-to-end DAO ACK or equivalent, okay, then great. That goes in the other document of things. So the purpose of the low-hanging fruit document that we think we can do quickly is that nothing in it should be controversial.
Yeah.
Because something. Now, you just clarified a bunch of things, which now makes a bunch of things potentially completely non-controversial, if that's what the clarification is. And so that's all I want, is so that there's no further, concern or whatever about what does this mean or what does this do. And this business with the bottom up, that sounds great. I never conceived or understood that from, the last time I read 6550, but that's really, I did not know that. So that's really important. That's why I'm trying to capture is there's a bunch of knowledge that we haven't all come to, and we'll go back to 6550 and go, oh yeah, that's what that paragraph meant after all. It was never really clear to me when I read it. I needed a bigger example to explain it now that I've implemented it. And Pascal already conceived of it 10 years ago, so it's gone. So that's what I want. That's really what I want is to capture all that stuff quickly. Thanks.
Thank you.
Thank you very much
Thank you
for the presentation, but is it clear to you what you're going to do?
So I think some of these things we can take it on the mailing list. For example, what are the things which the working group thinks is non-controversial, can be used,
Very
can be
good.
updated as part of
Excellent.
6550.
Yeah. We'll be fine.
And the other part we can see how we can take it as a separate document.
Okay, very good. A document with a statement about the problem and the solution then.
Yeah.
Yeah.
Pascal, that was my question. Can you clarify this? Everything is in there must be captured, stay, be document, blah. I would just want to understand what's the future, right? Is this document like a prime statement document and put it like that? Or do you want to evolve part of the solution in the same document? How do you want to structure the work?
The current document at least is purely problem statement. There's no solutions discussed there.
Yes, I mean, I like it like that because now we have a repository of our primes.
Well, what I was thinking that we don't want problem statements to be unless informational. As he can separate in different documents and he can motivate why he's looking at the problem and then give the solution, I think it will be perfect document.
Yes.
Okay.
So do we keep this one and then write new documents where you've got a piece of the problem and then the real solution pointing? I mean, how do you structure that?
Yeah, we can have maybe a main document with the problem statements and then that one as well pointing to the solutions.
You don't have to publish the prime statement. We just keep it alive.
Okay. Yeah.
And then at the end, maybe everything fits somewhere, but if not, we still have this.
So your proposal to have a draft with the complete problem statement, and then this draft will slowly disappear once all the documents are published. That's great. Well, that depends on how you see the work.
We did that at 6law, right? I mean, we had a problem statement draft for a long time. Now it's dead, but it's actually an appendix for the main spec which solves that.
Yeah, I think so. So basically, you're saying that we keep this problem statement document as a things to track. Yeah. Yeah.
Okay.
Sure. Yeah. Some of the sections here. Yeah. Okay.
Yeah, in an earlier, Cosmo, in an earlier life, when I was chairing the ROC working group, we had a standing document for about 5 years that documented problems,
Yes.
unclear things, frequent misunderstandings, and finally we published this at some point, but we left it as a standing document for a long time.
I think Carsten is talking about clause and LLN experience document, which is actually
I'm talking about RFC
No?
48.
Oh, it's a RFC.
So that was
Okay.
some
Yeah.
All right. Okay.
ROC
Clearly mistaken
Yeah.
here. Then.
But yeah,
issues and corrections.
we have this case as well when Michael write this template for applicability statements. It was like a draft, and
Okay.
then when all the
Thank you. Thank you.
and yeah, thank you very much. Paul. Yeah, who has read the draft? Oh. Yeah. Who is willing to review it? Great. Yeah, we need it. Thank you. Okay, next one. Carsten?
We have this discussion now if we want to introduce beer into Ripple. There has been an earlier document by Karsten who says how you could do multicast by using beer. There will be another presentation later on by Pascal to see the different modes of beer you can use, and also for unicast. And having all these proposals, we wanted in the end to start a design group with the agreement with the working group to look at this problem further, how to put beer into Ripple. Sorry. Yes, Karsten, please.
Yeah, thank you. So yesterday in a week I was talking about stuff that was more than 10 years old. Now we are talking about things that are that is more than 5 years old. Interesting nostalgia-based idea here. So basically, the observation was that it would be good to have a multicast for non-storing mode, and we were thinking about good ways to do source routing for multicast. So that was a research project that we started some time ago, and we came up with a solution that we called constrained cast, and that actually was a result of a research project, but not necessarily a draft that we wanted to pursue here in the IETF. And then in 2014, beer happened, and we saw, there are other people who are working on source-routed multicast. It's not exactly source-routed in beer necessarily. It's maybe routed somewhere else, but this draft suddenly, this research suddenly became interesting again, and we submitted it as a internet draft, and it spun for a while and became a working group document. But it certainly makes sense to do a revisit of what's actually happening in the beer working group and see how that is applicable to what we are doing, but maybe also the other direction, how what we are doing actually can be useful in some deployments that what beer currently has doesn't fully address. So I have presented this before just to remind people what this was about. So to source route a multicast in non-storing mode, the source routing always comes from the root. You need to put information into the packet for every forwarding node that sees the packet to decide whether it has to forward it or not. And of course, one way of doing that is just listing the forwarding nodes in a source route. But that becomes big very quickly. even with great 6LoRH compression and so on. So what we looked at was what are efficient representations of lists of data, and since 1970 actually, we know about Bloom filters. I was 8 years old at the time. And yeah, that's a technology that was invented for the machines of 1970, which are constrained nodes by today's thinking. So let's pull out that idea and see how it works. And basically the idea is we put the outgoing interface addresses of the forwarding nodes that are supposed to forward things into the Bloom filter. And so every node can decide whether to forward a packet that it sees or not. So we can directly use the outgoing interface address. We don't need any coordination, numbering, whatever. So this is a small incremental layer on Ripple non-storing mode. And of course, the problem is that Bloom filters are probabilistic. So we have false positives. False positives cause spurious transmission, and the spurious transmission, of course, eats some energy somewhere. So we have to think about how bad is that in a specific situation. And how bad that is, of course, depends on the properties of the network. So there are a lot of things that go into that. So for instance, how full are your Bloom filters? And that, of course, depends on how many forwarding nodes do you have for a particular multicast group. And also, how many bits do you actually allocate for that? So you have a little bit of control over that. And if you have a very dense network, of course, you will have more nodes that actually see a multicast packet that is not meant for them and start exercising these false positives. So the density of the network also has an effect on that. So it's not something where you just write through 3 formulas on a sheet of paper and understand what's going on. But basically, the spurious transmission that we are seeing here is not doing any damage except for wasting energy and spectrum, of course. So we actually can live with a significant percentage of false positives, assuming that the alternative of putting large source-routed lists into each packet are also expensive. They also waste energy and spectrum. So it's a trade-off there. And the numbers, this is just an example. So if we allocate just 64 bits to the filter, which is kind of a minimal size, we can have some 6 or 8 forwarding nodes. And I'm talking about forwarding nodes. I'm not talking about leaves. I'm talking about forwarding nodes in a multicast group before we start getting 5% false positives. And then this, of course, the handling capacity goes up if we allocate more bits. And if we accept 30% false positives, which is, of course, significant, then we can do 100 forwarding nodes in 256 bits. So there is some scaling possible, but this is certainly not something that you would want to do for a very, very big network. But then enumerating bits is maybe also not so great for a very, very big network. Okay, so that's the basic idea of that draft. Pascal, you have to explain what the abbreviation BOC means. Okay, good. Well, you know, I've been the chair of the ROC working group, so I always was thinking about how to combine ROC and roll, but I haven't found a good reason for that. Yeah. Okay, so basically the question is, can we do the same kind of source routed multicast based on the beer architecture? And I'm not a beer expert, so maybe I should hand Pascal the pointer. But basically, there are more.
What's going on now?
There is one question.
Hi, Karsten. Matt Gilmore with ITRON. I had a question about the spurious transmissions you had on the previous slides. Is that because of hidden node problems? I'm sorry?
This one?
Okay.
Which one?
So, go back.
Let me show the slide again. So a Bloom filter works by making multiple hashes of the value and setting one bit for every hash. So when a node checks whether it needs to forward, it looks at its own bitmap and sees whether all bits are set. And what can happen is that bits from different nodes combine and happen to match the bits from a third node. And that's what this example is about.
Have you considered the fact that the node on the second hop can hear the DAG root and original transmission?
Yes. So you have to add in some rank information to make the whole thing work. I just glossed over
Okay,
that.
so you're assuming rank is still followed.
Yes.
Okay.
So we are using the Ripple structure here.
Okay.
This is just a little layer on top of Ripple.
All right, thank you.
Do we have any in this presentation, any of these pictures that show kind of the beer? Oh, sure. Okay. Right. So basically, we've got the beer stuff, which is kind of RFC now since a few months, and that's basically the architecture where every bit in the bit string indicates a leaf, a receiver. Encapsulations, MPLS, and anything else, Ethernet. So that's a flexible encapsulation. And then we've just started to adopt by the working group the model where every bit indicates an adjacency. So that would be for the non-storing mode where you indicate really the path through the network. There is also then an encapsulation for that primarily tries to add a sequence number so that we can do duplicate elimination, ref function, as they call it in DetNet. And then, the fast reroute things, we're still working around what that should be, because primarily, I think right now we would be focusing on, dual transmission, send the traffic twice through the network, and then do the duplicate elimination through the elimination function. And then Pascal had these great ideas on how we can actually use the bits in the bit string on the receiver side to also provide additional OEM functionality in terms of, okay, you've been sending this packet 2 or 3 times, and on the receiver side, you actually want to know, okay, which of these packets, which path did it actually go across? And then I can basically do even more diagnostics with that.
Thank you, Torres.
Pascal here. I've got some backup slides for if you ask me because we have time, I can always go through them to show you how beer works with Ripple with the proposal here. I thought that most people in the room already know that, so I just put that as backup slide, but just jump in and say, please present them. They're right here, or you can visit the slides after the meeting, or just scroll a little bit and you will find them. So what I wanted to illustrate here is that basically we have this matrix of storing mode versus non-storing modes, and whether you use the classical beer using bit by bit, a bit is one thing, versus Bloom filters, which can be seen as a compression form or an alternate form of expressing the bits, which has pros and cons that now needs to be discussed. But what I'm trying to say first is that the Bloom filter can apply whether you're doing storing mode or non-storing mode. It doesn't matter. Whether you express the address or whatever else of every hop, which is what source routing does, and TE does. So non-storing and BRT are really much in the same corner here. or whether you want to express the final destinations, which is what normal beer does, which is what our storing mode does. At the end of the day, you can always express those things as IP addresses, and you can always hash those IP addresses into a Bloom filter. So it's not a matter of multicast or unicast. It's not a matter of storing or non-storing. You can always do that. I mean, there's disagreement, let's say it now.
Yeah, just quick comment on that. Carsten Woman, yes, the guy with the German accent. So, I think it's important. Bloom filters can compress sets. So the source word normally is a sequence. So there is a little bit of there's a limit to what the Bloom filter can actually do for you. So if a set works for you, that's fine. And for us, it works because we also have the rank information. So that creates the sequence.
Okay. So I started this draft much later than Carsten's work because I just showed at some meeting how beer could work for REPL, and then the chair asked me to write up something. So I wrote up something. I hoped actually that Carsten would join. So what I did is I tried to write something which shows that you can do all four, and try to present this as an option on top of doing just beer by bet. That's how I structured this document. That's why I have those arrows here, which show you that actually you can do all four. But my main interest when I started presenting this was this square here. And the reason why I'm mostly interested in that is one of the reasons why storing mode is not so successful in the IoT space is because it consumes resources in individual node, and the amount of resources depends on the total amount of leaves that you have in the network. Now, if you express those leaves as a bitmap, so say you have less than 200 leaves in your network, a bitmap of 256 gives you some elasticity there, and you can express everybody. And now the amount of state that you have to keep in every individual node is no more the number of leaves in your network, but it's the number of children that this node can have, right? Which can be controlled. I mean, with REPL, we yet don't have those extensions we just talked about to control how many children or what. But that's something that can be controlled. So all of a sudden, even for smaller IoT devices, thanks to beer, storing mode becomes possible. So that was my lead interest in using beer for storing mode, making storing mode alive again or something, great again. So there we go. So basically, the main question that the group has to sort out is how we want to structure this. I mean, we could have a document here and the code document here. We could have a document here and just something which says how you do beer, regardless of whether the address you're talking about is the next hop or whether it's the end of the path, right? We can structure this work in a number of fashions. So that's one of the questions we have in front of us. And I tried to actually document more that aspect than the actual operation of beer in REPL, but I actually documented that as well. But I kept completely open how Bloom, because I really thought that would be Carsten's interest to work on that. So this is what I'm trying to express here. Keep in mind that BRT is all about specifying bits for each hop or each segment that you want to follow. So if you look at what Carsten expressed is in constraint cast, it's pretty much the same thing, right? We express the different hops that the packet has to follow, and then the false positive are I computed a mix of two hashes, and I thought it was coming from the same, so I forward this way, but actually this was coming from here, this was coming from here. So I have a false positive. That's how I end up forwarding to the one guy. Question, Thomas?
Yeah, so no, just maybe kind of to up-level this, right? So before I think maybe doing all these decisions of drafts and all this stuff, don't we want to first have some, rough characterization of the resource requirements that we get with the different options, right? So we see a bunch of options on the
yes,
table.
I mean, we have to sequence the work.
What's the state that we need intermediate? What's the overhead in the packet? And then I guess with the Bloom filters also the stochastic analysis of the redundant excess traffic, right?
Uh-huh.
High level kind of what is necessary as a first step for this to make decisions for the next step.
Right, and there is a side aspect to that about Bloom filters. Is in the one hand, this fits the beer architecture. This is something novel. We may have to talk to the beer working group and see if there is a wider interest and how that fits there. I see people down there. How that fits the beer architecture, if beer in general is interested in looking at that. So all those points, yes, I'm interested completely.
Yeah. So Carsten, I'm not sure we will be using the MPLS encapsulation. So maybe the ripple form of this is actually different from other forms. Again, as I said, we are using the rank. So this is the constraint-cast proposed that this is closely tied to having ripple below it. So to compare the various fields in this matrix, which I very much like, to do the bit-by-bit thing, where it doesn't really have to be bits. There are other good ways to compress bit fields. So that's a different thing. You have to number the things that make decisions here. So you either number hosts in the storing mode column, or you number forwarding nodes in the non-storing mode. So that's one different.
Well,
here.
We'll have to decide what we number. I mean, that's part of the work. But yes, the number, the amount of information is correct.
Yes. So we need a protocol that does this numbering, and I have expressed some concern that this protocol will need some robustness to actually work in a dynamic network.
Yes, I mean there are answers to that. We already give away short addresses in those networks, in our networks. So that we can hand over a bit at the same time if we like.
For short addresses, we usually have densities of using the number space, which are low enough that we can absorb some churn, because we just leave the address allocated for a while and so on. If we do this for the bit allocation, then of course we are not counting the number of hosts, for instance. We're counting the number of hosts plus such as churn factor.
Yeah.
So that will need to be taken.
Yes, and the alternate we had in mind was link that to 6LoP because you actually lock. You actually register an address, go to the 6LBR, and the LBR as your address can map it with a bit, and usually it's collocated with a ripple route. And it has a lifetime, so it knows it's like a lease now. It turns over these bits for this lease time if it's renewed or not, and then that's how it would be maintained.
That's the easy part. The hard part is when do you actually reallocate this bit to somebody else?
Well, yes.
So
after lifetime.
That's why you need this churn factor to
the churn helps, averting small overlaps, but you have a lifetime.
Yes. So you have to look at the details of that.
Yeah. Yes. I mean, I understand. I mean, that's. Churn helps.
So apart from that, we need a couple of fields in a few messages to actually carry around this bit number.
And that I think all this goes into Torles' proposed work, which is how efficient are the bits, right? In the one hand, you have the numbers that you showed about the Bloom filter, which says, okay, with 100 hosts and 256 bits, I get this 30% or whatever. I mean, those are numbers. Of how big the Bloom filter has to be. The bitmap has to be bigger than the number of hosts because of the churn. So then again, it's not, I mean, you have a loss. So we have to compare all those losses, basically.
So I think what I heard Carsten saying was maybe what I was thinking the second step, which is kind of exactly this, what's the control plane necessary to do the management of the address space, right? And the question is a little bit, should already start brainstorming at least the rough mechanism, not the exact protocol messages that we need to add to
The control plane is the easy part. The easy part, I think, if I understand well, Karsten, and I would agree with what he said, is the hard part is I have 200 hosts. How many bits do I want? Because I have churn, right? I want to keep some buffer here so I don't reuse a bit too fast. And
if you don't call that control plane, how do you call it?
Well, that's really the decision of setting. The control plane for me is the protocol which goes and give me a bit.
No, that's
yes,
the
here
protocol.
You go. Right. Yes,
No,
I meant
common,
protocol.
Common terminology.
Okay.
I think we're in violent agreement that kind of this management of the address space is, another big block. And the question is, should we already, in the beginning, try to at least lay out what the options are?
Yeah, exactly.
We can leverage ND for the bit assignment in the left case. We can leverage Ripple for the bit assignment in the right case. So we have enough places to put this information, but we have to write up one choice at some point for that part. What we also could do is increase the number of rows in this table, because we can look at other ways of compressing the bitmaps. And I think that there are some pretty good ways, and these pretty good ways may actually get close to the efficiency of Bloom filters. So I think that's something that's worth looking at.
So are you talking about basically I have a bit by bit assignment and then I compress it on the wire?
I compress the bitmap
on the wire, but it's still semantically it's still the same bitmap. It's just
yes,
because this is completely different, right? That's why for me these are two.
It's
really
also a bitmap. It's just pretty large in the uncompressed case because
I agree. The point being that you're still there, but you compress it.
Yeah,
and so it's not as big as a semantically.
Even put the assigned numbers into a Bloom filter, which probably doesn't make sense because the IP address is hashes as well as the assigned number. So there's a little bit of space between them that could be used up to probabilistic compression, which could be used for really large networks. That's the vertical part, and on the horizontal part, I'm only interested in the right half. So do whatever you want.
Yeah, I know you're only interested in that half for the non-storing unicast world. I still fail to understand why you extended this condition for the multicast, because as soon as you build what you build, constraint cast, and you have the destination IP address, and you have all the hops because you learn them from. So you're doing non-storing mode unicast. You're in that world. You have all your addresses. You know how to do. You're an existing network, and now you know how to get to any IP address at the leaf. You know all the leaves, and you also know the path to the leaf. So at some point, I was wondering, hey, why don't we keep what you know for the? I mean, why don't you do an extra from?
Let me give you the answer for that. The non-storing case is slightly simpler because the actual source is always the root.
Yep.
If you have a source somewhere in your tree, then you have to work with both the upstream and the downstream case.
And just cool, because you may have a false positive because you only have Okay.
It becomes a little bit more complicated.
I see.
Because you cannot
It's a good answer.
do the ranking thing to control that.
I understand. Because if you're not doing Bloom, that's not a problem. But with Bloom, it becomes a problem. If you're not doing Bloom, if you send a packet from down, as long as you don't resolve all the bits down, you still have to copy up. But you can still forward with the bits. With the Bloom, you never know. So okay, I see. It's one thing to mark in our list of procons or capabilities. The bit by bit allows you to send a multicast packet from inside the network. It's part of the differences. Much easier. Okay, so I don't know how much time we have. We were really in the middle of the discussion we wanted to have.
We have 25. You have 25 minutes still.
Loads of time.
You have lots of time. Okay. So actually, we started discussing what I had as questions anyway. So what is the protocol to allocate a bit? And as Karsten said, I mean, how many more bits do we need than we have addresses, so we can keep, do least recently used, blah blah blah, a bit allocation. packet compression. I mean, it's not just having the beer, but we also need to transport the bitmap in the packets. So we have actually started a 6-law draft on that. It's not very live. It's just to show you can do it. If this group now starts working more actively on beer, then certainly I will revive this work and push it. We have to change REPL. Whichever solution we take, we need to be able to express new forms of DAOs. So we express bits as opposed to addresses, right? And as Karsten said, that can even be compressed a lot, actually. And that points to another thing, which is we always said we would compress REPL mechanics. We never did. So, yes, I mean, the DAO, DIOs, and those things. I mean, and then we've got how we do we handle. I've got more hosts than really I feel safe to handle with my bitmap. What happens? I mean, do we make groups? Do we? I mean, that's another. With Bloom, you've got actually a benefit of, okay, if I'm beyond the statistics, I hope that really increases my false positive, which increases the number of packets in my network, but I still work. In a bit-by-bit network, if I have more hosts than I have bits, then some host won't be served. Or I will start to give the same packet to both hosts all the time. I don't know. And for the BRT, then I know a number of responses to that in Karsten's document. Actually, reading it, it was very light. I mean, Trav could have put more words in explaining all this, but I mean, we have a number of answers. What we place as link ID could probably be the IP address of the next hop, because I'm not even sure if it's the next hop. I guess it is. Then same question about 6-law array, same question about REPL, same question about bit overflow management. I mean, what do we do when our bitmap is too small? Do we need to renumber the whole network? Do we have groups? Group 1, group 2, etc.
Sorry, totally clueless, but what's the mandatory native forwarding plane? Does it kind of within the domain have to be an IPv6 packet at the outer side, or could that actually be, also a beer packet, right? Because we have all these, overhead right now with, the IPv6 in IPv6 encapsulation, and so I was wondering if we can replace the outer IPv6 header with a beer header.
Yes, actually, it's whatever we like, because we have this 6-law RH compression mechanism, which already compresses the IP in IP and dramatically to almost 0, right? So it's all implicit somehow. Okay. You derive it from something. So at some point, this draft does it. We almost carry only the bits. But we say how you could reconstruct the whole packet if you really want to show that we stick to the IPv6 architecture and to the beer architecture. There must be a way through all those implicits and to reconstruct the full IP packet, but we never use it. We actually forward the packet in the compressed fashion, meaning that the only thing you will see mostly are the bits. So officially we comply to the architecture because you can always reconstruct the packet. So since we have a little bit more time, I will just show you in a few seconds just to see if we have reactions here and we have new people, how we thought the unicast would work. And then, but basically the multicast is pretty much the same, but it's very simple. So REPL builds directed acyclic graph towards roots, right? So in my case, I have 4 roots here and the backbone, so I have 4 directed acyclic graphs. And so I just picked one and I gave an address. Every node has formed an address, neighbor discovery, autoconf, 6-law IND, blah. And in non-storing, so I just picked the case of non-storing, it works either way. In non-storing, a node, a device here will tell the root with a unicast end-to-end message, I'm F and my parent is B. B will tell the root, I'm B and my parent is C. The result of all those advertisements is that the DO DAG that has formed as a wave outside of the root is told to the root as a sequence of vectors. So all those vectors are expressed one by one to the root, and the root is capable to reconstruct the whole geodag. So these vectors are expressed like a target and a transit, right? Target to transit is an arrow here. So actually, it's interesting because I picked the non-storing when I made this example. I thought I picked the storing. Well, this is past. Well, forget about this. This is just ways of allocating the bits that we discussed in earlier meeting. So say we have allocated the bits here. Okay, so each node has one particular bit, which is mapped to, you said the node ID could be just its one IP address. If you use 6LoWPAN-ND, you will register an IP address, and for that IP address, you will get a bit. That's one way of doing it. And so for each address, now we've got a mapping bit, right? No surprise for the beer people. And so that's where REPL starts. So in storing mode, you basically tell your parent, here is my address, and all the children do that. The parent aggregates all those addresses as here is what goes through me and tells that to its own parent with its own address added to that. So that's how you paint the geodag. So REPL has this first wave which creates the geodag, and this return wave which paints it with all the prefixes. And since it's a distance vector operation, you only need to know who is reachable via whom, right? And that results in as many reverse geodags pointing to all those addresses, which are just following the same geodag as the other one, but the other way. And so that's what I'm expressing here. So node F here will be telling B, A, I have this bit here. Node A will be telling B, A, I have this bit here. B will keep the bitmap for all its children and only its children. It will aggregate that with an OR operation. So it will aggregate its children and himself. So that will end up with this bit for F, this bit for B. Sorry, this should be for A, and this its own bit. And that's what it sends to its parent. So you see 3 bits now, A, F, and B. That's the result of the OR operation. And you keep ORing all the children and maintaining the bitmap for each all of your children, right? And and you end up at the root here, which has, I picked as many bits as host, so you get all the bits set somehow.
Pascal, in case you have too many children, and you have...
That's the problem of the bitmap, the management, right? What do you do when you tend to overflow this? And that's a question to be asked. I mean, in beer, you can do groups, right? You can keep the same, but you have some bits to say a group, but then when you send something to different bits, which are on different groups, you need to send different messages, one per group. So that's one way of handling it. So this is basically telling the story that I just said. So you see the bits aggregating. So now you see this path, for instance. So I and G end up in K. And this is basically what case is, right? Case is E, this is I, and this is G. It keeps that. I hope it's clear by now. And so when you have a message, and I'm just talking about the message down, but any node which would get a message to a certain bitmap could forward it from any place, and it would still work. Let me show you what happens for a message from the root. So the root will look at the one or multiple destinations that the message needs to reach. A unicast is just a special case. And so it just computes the destination bitmap as the OR of all the destination that you want to reach. So for instance, you want to, I don't know what example I have, but you want to reach 2 destinations, you just create the bitmap of those 2 destinations. And now as the packet is forwarded, the node will look at all its children one by one, and it will do an AND operation. The AND operation between the bitmap of that child and the bitmap of my destination, if the end is non-zero, so there is at least one bit in common, that means that this path is going to one of the destinations. It's a pretty easy operation. So you have an optimization if you find that the bitmaps are pretty much all your children. You just broadcast it as opposed to selective unicast one by one. As opposed to BR, you don't have to reset the bits as you forward because it's a DODAG. Right? The bits can be sent and they will be useless from then on. It's an option. We have to decide that. If you want to route up, you will have to erase the bits. And this is an example, message to AF and J. So you end up building this bitmap. And if you look at the slides, you will do the forwarding operation. The interesting thing, and we discussed that last time, is we can also make that reliable, kind of, because once the packet reaches the destination, they can send back an acknowledgement and with a bitmap as well, and the bits can be ORed as it flies up. And the result, when it reaches the root, is the OR of everything, so all the nodes which got it. So the send bitmap minus the ACK bitmap gives you the missing bitmap. You retry that. So that's an interesting side effect. So if you only route from the root, then you can avoid resetting the bits. If you want to be able to send a packet from anywhere, which is the new thing that we just discussed with Kirsten today, then you need to reset the bits following the BR architecture.
Thank you very much, Pascal. I wanted to see if there's interest in this work for this work in the working group. I mean, there's already been a considerable effort. Not to influence you, I think it is very interesting. So maybe I can have a hum from the working group if they think they should take on this work, Ripple with beer. Please hum now. Anybody very against this idea? So please speak up now and give your reasons.
Cosmo, I don't like talking about things I don't know anything about. But there's always this 800-pound gorilla in the room that we don't see, which is called IPR in the IETF. So that keeping things simple might create a draft that is easier to control in this space. Covering the whole floor may be more difficult to control.
Okay. Well, one of the things that we thought the way forward was to start a design team with a select number of people, and that they will look at the work, analyze what should be done, and come forward with alternatives if needed. Tell them in what circumstances it is interesting to do this, then Ripple will profit, and also to see what kind of documents we need. That was the idea for a design team.
Can all the companies that will send a patent attorney into this design team please speak up?
Excuse me? Okay.
Isn't that always the case? Kind of, you know. Yep. I would think that if we do a design team and then I think afterwards the thing would be, okay, if we adopt, let's say, this option here, does anybody know what IPR somebody has on this? I mean, even if you think something is simple, doesn't mean somebody else hasn't already tried to put a patent out, right? So maybe your Bloom filter, just because all the stuff is so old, they're all expired, but right. No, but I think it's a fair point, and I think that may be exactly why, you know, first doing a design team, maybe coming up with some options, and then, you know, if we're afraid of IPR, let's just simply have
and they can announce that then. Okay. Very good.
We can't make judgments on what we don't know, but if at that point in time we get, you know, something, we learn something we don't like, then we can take that into account with the next step.
So that's the idea of the design team, to remove the gorilla and get just a small monkey. Yeah. Thanks. There were already suggestions for participation in the design team. That's Karsten, I hope he wants to do. I mean, we really appreciate it. And Pascal, I think you certainly want to participate in the design team. Tourless has been volunteered. So that would be nice. Linda was. Oh.
Emmanuel.
So I'm volunteering Olaf, who actually did the work on this.
Olaf is doing the work. Okay, so you're volunteering, but there is a direct pointer to Olaf. Okay, very good. Then there is Greg, I think. Yeah.
Okay. Ice from Cisco. So I did a bit of work on the beer side, the beer working group. So I would like to volunteer as well for the
very
team.
good. I think we have a team, huh? Yes. Yep. Okay. Can I ask Tourless to coordinate the team? Yeah. Okay. And then you try to come to a conclusion, see how the design team looks like, and tell them at the next meeting, or maybe before already, have a document in which you say the different alternatives, when it is useful to use, and what kind of documents we're going to look at, and possibly the IPR involved. Then. Is that correct? Yeah, is that clear? Yeah. Okay, thank you very much. It was a difficult subject. I'm glad that we are making progress here. Thank you. Okay.
1.5 millimeters, right, Karsten? 1.5. There we go. They've adjusted it. Yeah, I know. I could notice that I could hear them despite that. So since yesterday, these slides have been updated. So slightly. We had a very productive discussion yesterday in the Code Lounge to understand some of the issues. So this sounds like nothing at all what we talked about in 6-dish yesterday. That's a good thing. It means we've improved. Just how many people were there yesterday in 6-dish? Okay, so not even half. So the rest of you, this will be a little bit new, and that's good. This is just a little bit what we're going through. This is basically a set of requirements coming from 6-dish into roll to do some things, and to deal with some specific problems that, they turn out to be roll problems that we have in 6-dish. Okay, so they're not specific to 6-dish. Actually, they're very much not specific to 6-dish. But in 6-dish, we have a specific way that we wish to solve some of the issues. So that's why, and we have a way we want some layer 2 things that we're going to do. So which button? There we go. So this is a complicated network that Pascal drew a while ago. We have a blue network. We have a green network. The blue network has some kind of a backbone happening and has a number of DODAGs. In some discussion back and forth yesterday, there was some discussion as to whether or not these were different PAN IDs at the 15.4 layer. And this matters because if they're different PAN IDs, then they probably most certainly have to have different keys. And that means a single node sitting here can't necessarily hear this and this network at the same time because it doesn't necessarily have all the same keys. Now, there's 2 aspects to this. There's the problem of enrollment. So this is where you first join a network and get the keys and do some things. And in that case, it's very important that you find out which ones are the green networks and which ones are the blue networks. Because if the blue network is not your mummy, then you probably shouldn't join it, okay? But the point is that if you hear a whole bunch of things, one from here, here, that's a lot of things that you may have to go through. So it would be nice, what we would like to have in 6-dish, and we have a way of doing this, is to identify the blue networks as being blue and the green networks as being green without disclosing anything to an attacker about what's going on. So the important thing is that if it turns out that you're supposed to join the green network, it would be nice if you tried one blue network and then put all the other announcements that you hear to the bottom of your list and tried the green network. Of course, if the green network didn't work, then it might be that the blue network you saw was a malicious attacker, and you should try a different way. So you do have to try them all in the end before you can give up. But as soon as you succeed with one of them, then you're golden. Okay. So to that end, we are. So it's just So there's the other aspect I want to go back to this, which is that having joined a network, there's then an issue the first time. There's then the issue of, well, did I attach to the right, not to the right parent, because that's parent selection, but now did I attach to the right DODAG? Because it could be that this guy in the middle will be much better over here than over here. Okay? And so then we have this issue that we need to do essentially DODAG selection before we do as part of parent selection. And that becomes a challenge because there may be different keys and there's other stuff like this, and you can't hear the DAOs and you don't get all the metrics. So there's some issues there, some overlap between essentially layer 2 decisions and layer 3 decisions. And we're trying to get the right information to the right places so that we can make this thing. Karsten, you have some comment at this point.
Yeah, Karsten, just a weird idea. So if there were a secret handshake that a pledge and any node in the network could exchange with each other, this all would become very simple, right?
A secret handshake. So in fact, this guy would be able to know this guy's without exchanging any information? What do you mean by a secret handshake?
Well, the idea about a secret handshake is that none of the two parties that do the handshake disclose anything to a third party, but they do disclose to each other that they are a member of a group.
So I see where you're going, and that may be an interesting addition, but I don't think that our problem that we need to keep secret the existence of the blue network or the green network, or the fact that this guy and this guy are part of the same network. So what your would solve is it would allow an observer to not, it would prevent an observer from noticing that blue over here is the same as blue over here.
That is not your objective?
That is not our objective.
Oh.
It is an interesting objective, but that's not our objective. The objective here is that this guy, who is potentially, well, maybe an attacker, but it potentially is an interesting, a non-malicious node, let's say for the moment, would like to avoid going through all of these blue networks just to discover that he belongs in the green network. So it's a head of queue problem.
We do that with SSIDs today.
Yeah, but we don't have SSIDs in 15.4, okay, and we don't know how to select them, okay. So in some sense, this is an insecure SSID for 15.4, if you want to think of it that way.
Okay, it would be hard for a network to just generate a 128-bit random number and use this as a network identifier?
Well, in fact, that's what's on the next couple slides in the future, right? So we don't. So the other thing is that in some sense, Pan ID is that thing, but Pan ID has some other. It's too short, but also it has some other operational issues that are issue. So as I said, so this node, it may be better. Particularly, you may find that this part of the network is too congested and wishes to move over here. Okay, and I'm not at all going to talk about how the decision is made, but rather how the information about the status of this network occurs. Okay, so don't ask me questions about the parent selection involving multiple things, because that's Giorgio's problem. Yeah, right. Okay. So I just wanted to make those clear. There's two parts to this, was enrollment and parent selection. If you saw the slide, we had some dispute because I didn't really see how parent selection fit into it. And I now understand, at least well enough to update my slides, if not well enough to update the document quite yet. So clearly the blue and green networks are different. Blue network, in this case, there's 3 PAN IDs, and different PAN IDs leads to different IPv6 short addresses. So if you have different PAN IDs and you do it because you needed more bandwidth with different schedules and things like that, then I think that one of the effects is that you don't get, what was the word you used? Transparent, no, painless, no, use another word. Seamless movement between the different DODAGs. You would have to renumber as you moved from one DODAG to the other. And that's a compromise. You can also build this network with all three having the same PAN ID and the same network, but then you get into issues with synchronizing the ASNs and things like this if you're doing 6-tish, and cryptographic reasons. So you probably wind up are forced to have different PAN IDs if you have overlapping networks. If on the other hand, this is not the case, you're the green network, you just build a really big green network, and you just happen to have multiple attachments to the root, to the core, that may not be an issue. Okay, your DODAG could extend up to something here, with this really being the parent and really all being one DODAG, and all one PAN ID, just multiply attached. The highest levels happen to be Ethernet rather than 15.4. That's a different problem we're not really specifically dealing with. So in 6-TISH, we've changed this diagram probably 12 times since yesterday or something like that. So we are going to create an information element using the IETF allocation that's now available. It will have something called a proxy priority, which is essentially determined by, if you want to enroll, how likely is this proxy going to be able to help you? So for instance, how many neighbor cache entries does it have? We heard Raul's simulation was 8, right? Well, no, it was not you, it was someone else previous to that, had 8, right? How many do you want to allocate out of your 8 neighbor cache entries to an untrusted node that you don't know who it is to do enrollment? The answer may be 1, possibly 2. For that 8, I'd probably be skeptical of 1. So if you've already got something going on and it's continuing, then the proxy priority probably needs to be a very undesirable value, such that you don't get any more nodes trying to join. They'll try joining through some other proxy. On the other hand, you've got 128 entries. You could devote 10% to that easily, and you could have a very much better. R is a bit that essentially allows us to say that this node is a router from the 6-man point of view, and would accept a unicast router solicitation. And the reason why you'd want to do that is because the alternative is that the new node, or the leaf node, and if the leaf node would have to either, according to the rules, would have to either do a broadcast router solicitation or wait for a broadcast router advertisement. Okay, so this says, hey, you can form with my layer 2 address, you may send me a unicast router solicitation to get a unicast router advertisement, which eliminates the need for a leaf node to tie up a broadcast slot in the schedule. So that's sort of a separate thing that's happening in there. We have this network ID, which used to be 16 bytes, but is now variable as of yesterday. And it's probably something like a truncated SHA-256 hash of your prefix. But we've decided it's set at the DODAG ID, and that's all anyone else needs to know. The root sets it and tells people about it. Finally, we have this DODAG priority, which is the relative importance of the 3 green pieces. Okay, and that's set at the root based upon some knowledge it has about the traffic through its part. How congested is it at the top? How willing is it to accept new traffic? That's not just for enrolling nodes, but also for that node that needs to jump, that's already enrolled, that needs to jump from one network to the other because the ETXs are too poor for some reason. So that's what 6-TISH is doing. Okay, so proxy priority is primarily a local thing. The R bit is primarily a local decision. The DODAG priority and the network ID need to be transmitted, and that's why we're here. Karsten.
Let's say I'm an attacker and I want to attack the privacy of the potential joiner. So I just send one of these with the right network ID and a high priority.
Yep. Come talk to me. Yep. And the node attempting to enroll will attempt to enroll, and we have pieces above this in the enrollment protocol that assume this and detect that you don't have a legitimate claim on it.
I'm not talking about that. I immediately find out that there is a node somewhere who would like to join the network.
Yep.
That's information disclosure.
Yes, we agree. It's information disclosure. Yes, absolutely. Okay, so we have this problem, right? At some point, somebody has to speak first. Okay, for people for note. Pardon me? Right. So if you want to create a secret thing and we can do this in a zero-touch way, then I'm all ears. Like, tell me how to do it. I don't know how to do it, but it could be that you know something I don't. Quite lightly. Yes.
Thomas Watena. I'd like to stress that. So we had this long discussion yesterday about this. Is this working? Yeah.
Yeah.
And I'd like to stress that this is a problem that I face, very often while deploying these things with my company. You have different essentially DODAGs that are deployed in the same space, and a new node has to pick which one is joins. And so without something like this, it will try and try and try and try and try until it hits the right network. And that's a waste of energy, it's a waste of time, it's frustration for the tech guy. So this is a way of announcing with the network, what you call network ID, announcing that you're attempting to join what you believe is the right network. You may join, you may join, as Carsten was saying, you may join the wrong one for the wrong reasons, but joining will fail, and so you'll try the right one afterwards. With the proxy priority among the different DODAGs attached to the same prefix, essentially, which ones you should prioritize over other ones. You don't want to attach to a network that's completely congested and then have another network right next to it that is completely empty, and you should attach to that empty one. And then the DODAG priority is something that, the proxy priority is something that, is more local. But I want to stress that this is coming out of the real use case. It's not something we made up.
I can only agree with Thomas because our own networks are hitting the same problems. And it's more than, probably the one I'm most interested in is the DODAG priority, because basically what that tells you is when you see multiple DODAGs, and that's true for the join process, the enrollment, and that's true for the life of the device will see multiple DODAGs. And what we see in the field is that there is an instability in the structures that we build. For instance, if one DODAG has a lot more devices and traffic than the next, what's going to happen is there will be a lot of load on the radio, which will create loss, which will force the ETX, which is one of those metrics we use a lot, to go down. And as the ETX goes down, then the rank goes higher, and all of a sudden the DAG next to you becomes more desirable because the rank looks better there. So nodes move like as a bunch to the next DODAG, and guess what? You create one of those oscillations. And that's something that we actually see in the field. So it's not just about defining a DODAG priority, it's about defining it well. It's about expressing, it's something which mostly hits the root, right? The load at the root is mostly the load of the network. So we have to carry that over repo from the root down to the devices. And we have, just carrying a metric is not that hard, right? Just at this field in the DIO. But it's the real problem is this control loop, which will stabilize the two DODAGs one next to the other, so that they will end up in a situation where they are evenly loaded or something. And it's even defining evenly loaded is not easy. And so the work we have to do there is not just to pass 2 bytes in the DIO, is to understand how we can end up with a balanced and stable condition for the runtime of the network, having a rank like that, which is a DODAG level rank.
So the last thing to say is that we had a rank priority, which was really the DODAG rank, and then it was pointed out to me that the other information element in our beacon already has that number in it. So we didn't need to repeat it, but it was news to me, so I wasn't familiar with that part. So this just sort of describes a little bit of the things, and I used the word, I said preference, so I made a mistake again. I tried to consistently, I did it all here. That's what I get for doing it at 7 a.m. this morning. I mean to say, wherever you see preference, write priority, and trying to consistently say priority where lower numbers are better, okay? And preference is ambiguous for many people as a term. So what's the role part, okay? So I haven't updated this document yet, but it has some of this. So we want to have what I believe is a new metric option, new metric container, which would contain the DODAG preference. I'm pretty sure it needs to be a metric because it needs to show up in the DIO and it needs to be refreshed, go down the thing. Whether some other objective functions would do anything with it, the answer is no, but as a metric, it would be transmitted unchanged from one layer to the next, okay? And then I've put this in here, and I think that's just because it was in the previous thing, and I'm not sure it has any meaning, but I think it gets removed now. It was there from before. And then I think we have a new DIO configuration option, and that does not change much or ever. So it would go in the DIO configuration option, which is sent periodically, but not necessarily with every DIO in most networks, such that this network ID, however big it is there. And I'm saying probably it should be limited to 16 bytes. That's my suggestion. Pascal said, maybe 1 byte will be due, just XR together at one point. But what we've agreed on in the end is that it will be 1 to 16 bytes, and we already have a length to deal with it. So the overhead of making it variable size is probably not significant. And that's my suggestion. It's truncated SHA-256 of the PIO. That should be set in the root, but that it's up to the root to decide. It's not, no one else calculates it. So we need to send it through the network. It's two pretty small things. So we did this. The goals in 6TiSCH was to write it down, and 6TiSCH will probably adopt this, I hope, document to figure out what to do. And the goal in roll is to determine how the newly exposed metrics interact or derive from DIO things. In most cases, we've decided they're not. They were derived from things that you'd find in the PIO. For instance, at one point, the network ID was going to be the DODAG ID, okay? And we've agreed yesterday that that's not what we want because the different DODAGs would have different DODAG IDs, and so that would be an incorrect thing. But the advantage was that we don't need to transmit it if it's already there. So people have talked about number of children. There's a lot of other things, and we haven't expressed that. Although the suggestion yesterday was that the DODAG priority could literally be how many children you have in the whole DODAG, how many members in the whole DODAG, because as it gets bigger, probably the desirability of that DODAG goes down, which is pretty much exactly what you want. Of course, you might not want to disclose how many children you have, or you might not want to tell anyone that that's actually how you make the metric, but that's fine. I don't think we need to so we had some discussion about whether or not we need to standardize what the values are, because if you have a DODAG root, which is from different manufacturers, then they may do the calculation differently, which means that the values don't have the same relative value. So that's something to think about. We may actually need to specify an algorithm there. Okay, I don't know but what there. And that's it. And of course, what I would like is you to adopt this document here, or what 6TiSCH was like is you adopt this document here. So any questions?
Pascal, I just want to react to what you said about this metric. If you look at it, the way you compute this information is very close to what a normal objective function does. It's just not doing it for one node, it's doing it for a graph. But it takes into account maybe the number of nodes in the network, or the capability to get more nodes. Because if I have like a root which can have 1,000 nodes and a root which can have only 10, and one has the one with 1,000 has 100 more entry, and the one which could do 10 has just 2 entries, right? A ratio of what you can do is not the right value. The amount of how many you can still get in is more what you're interested in. So the actual number of nodes in the network, what I'm trying to get, is not interesting. The number of nodes that you can still take in is probably more interesting.
The percentage
is wrong.
Percentage full.
Percentage is the wrong thing, worst thing you can do, right? Because if my two DODAGs are very different in capabilities, a percentage of 10% left on the left might be one guy, and the percentage of 10% left on the right might be 100 guy. I want to join the right. So it's really the number of what's left, really. But and that can be discussed by the working group. What I'm saying is you're taking a number of metrics, like number of nodes left or something, amount of bandwidth left. I mean, the observation of the bandwidth being used around the root usually is what you care for. And maybe some other things which come from the nodes, right? I mean, if all the nodes in the network have their neighbor cache saturated, there is nothing the root can do, even if it could take more nodes. So it looks very much like putting a number of metrics together into a number again, like an objective function does. So yes, I agree we have to specify that at least one objective function. And it would not be an objective function to compute a rack. It would be an objective function to compute the DODAG.
And it won't be communicated. It will be configured on the DODAG root.
Right.
Right.
And the matrix that it needs, hopefully, are just local to the root. But it might be that some objective functions need information from the leaves or whatever else. I don't know. I'm saying I'm not casting in stone. Just like a rack can be built.
We don't know the loading right now. In storing mode, we do not know the loading of each of the children. In non-storing mode, we do. I know that some people would like to propagate that information up, and so maybe there's a connection right there immediately to doing things. Any other questions, concerns, any other objections to this work? You feel this is like just totally the wrong thing to do?
This is Peter van der Stok. I'm sorry I'm a bit slow, but I didn't quite understand what you're proposing.
Okay.
Is the parent selection included? Is the objective function included, or is it just a DIO description? I'm not quite sure here.
So it's just a DIO description of a container. Okay, one's a metric, one's a configuration option.
Okay.
That's the concrete bits on the wire thing the document has to do.
That's the document.
Okay. Then the document probably, as we just said, has to say something about the canonical way of calculating this. Okay, or at least for that there is and maybe even has an IANA registry for the names of these things so that we can actually talk about them. Someone will write a new document that says a smarter way of doing it at some point, if that makes sense. And clearly, if someone writes a Yang module for DODAG roots, it would have to include the name of this DODAG priority objective function in it so that it can be configured. But it doesn't have to be transmitted in any way, the way that our current objective function is described.
And the parent selection is in different documents, and also the order of joining a network and parent selection is in different
documents. So we're not dealing at all with parent selection at all. We don't care about that, but we don't care about the mechanism, just that we assume that there's some parent selection that can get better.
So we're talking about a rather reduced document with a clear objective, and it can
very
be
small.
quite
Yeah,
clear.
yeah.
Thank you very much.
It's not a lot bigger than this kind of stuff. Two diagrams like this, an IANA allocation for the types, and probably 5 pages of why are we doing this and security considerations and whatever. Good.
Did anybody read this draft?
Cool.
Are people willing to review the draft later on? Do we think we already should adopt it now or wait the next version? Mailing list. Good.
Yeah, I think we should wait to the next version, and then I hope we'll be adopted quick. But I haven't even done this stuff. We changed it yesterday.
Okay, very good. That's clear.
She has paper copies of all the RFCs here.
Okay, open mic. Some additional suggestions, comments? Yeah. Please sign the blue sheets. Yeah, Aris.
Hello, I'm Aris again. So this is my first time here, and I find all the problems that are being described very interesting. One thing I have to notice, though, is regards replicability. So a lot of the problems you describe, like the problems with joining or the balancing of the trees and the churn, I have to say, I don't know, maybe there's some repository I don't know of, but there doesn't seem an easy way for us to replicate these problems and be able to work on them. So it's very nice describing them, that you have real world networks which display these problems, but at the end of the day, since I'm not able to replicate the same network in a simulation, I can't actually attack the problem very well. So I was wondering whether there would be a way to share some of this information. I understand there are some confidentiality issues, maybe if you're working in companies, but even like that, I don't know, maybe there would be a way to share just enough information so that we can replicate some of that in our simulation and try to work with it.
Rahul Jadhav, I'm glad that you're talking about it. So replication is a big issue, yes. So we have been working towards a simulation framework towards achieving something like that, such that you just, for example, I face some problem. I should be able to send you just a configuration file, and you should be able to produce that problem.
Yeah, exactly.
So that is a work in progress. We call it Whitefield framework. So we are working on it, and it exactly tries to achieve what you're trying to describe here.
Okay, that's good. That would be very helpful, actually. Yeah.
Thank you.
Michael Richardson, what was the name of your framework?
Whitefield.
Okay, Whitefield framework. That's cool. The other thing that I was going to say is that I guess this F-interop stuff is coming along to be able to do things remotely. So it would also be, I think, really cool. I'm totally with you, by the way. And we've been through this over the 8 years of the existence of the role working group, maybe longer than that, maybe 10 years, kind of repeatedly, where we've had people say, researchers say, this doesn't work, and here's all the reasons. And then the working group has said, this is really interesting. How can we, replicate it so that we know whether we've fixed it or not? And then they said, oh, I can't tell you any of that. So, well, maybe you shouldn't have bothered. You kind of wasted your time, right? Because if we can't fix the problem and you can't talk about it, then I think you shouldn't even bother.
Yeah, especially in some of these issues which aren't, you can't actually just use a toy example to replicate them and fix
that's
them.
right.
You need some actual data, right?
And the problem with Kuya is wonderful, but last time I looked, it boots Kontiki, right?
Yeah. So
you can't replicate the problems that Rahul was talking about, where Kontiki versus Riot can't interoperate easily.
Well, to the extent that I think Kuja actually allows you to load any firmware. So if you are able to compile to a firmware which is simulated, then you can probably work.
But there are some restrictions.
It
has to compile to
MSP 430.
No. In many cases, it has. You're supposed to compile it. The Kuya actually loads an x86 file on your machine. It doesn't actually do a machine emulation.
I'm sorry, I'm not aware of that.
Yeah, so Kuya it actually does a native build so that the code runs natively, but it surrounds it looking like it's the target architecture. Now there are some improvements to this, but that's typically how you do it, and that's the only way to get the simulation to run quickly.
Okay.
Right. So there are some restrictions of what you can do, and what I hope is that something like F-interop will give us a better platform on which to run all sorts of native firmwares.
Okay, thank you.
So, yeah, that's the game, right? There's a lot to verify. There's a lot that changes all the time. So there's there's two projects I'd like to mention. So F-interop, thanks Michael for mentioning it. That is aimed at ensuring interoperability between implementations, which is one part of the story. I think you're talking about performance and replicating things like this. So Yach here is working on a simulator, the 6-dish simulator.
The Python one, right?
The Python one, yeah. That was released yesterday. 1.0.0 was yesterday. And Malisha, who's maybe here, is working on a web interface for that. And so the idea is that, of course, it's 6-dish at the root, at the bottom, but then there's Ripple and Cyclopan co-op and all that, and secure join. That will allow you to enter a scenario and get graphs that will give you a prediction of the performance of your network. It's not the answer to your question. There's no answer to your question, but it's like part of it, right?
Thank you, Thomas.
Thank you.
Thank you very much, Alice. Other concerns? Can we close it? Yeah.
Thomas, can you introduce tomorrow's session?
Yes. Tomorrow we are going to have a session as well. No. Wait. in the morning, and this is going to be the agenda for tomorrow. So from 9:30 to 11:30, we have 2 hours, and there's going to present like ODB Charlie, and Pascal is going to present his proposal about leaves, and then Raul with the no pattern modifications, and then as well now Pascal with the DAO projection proposal. And well, about this modification, it's going to be like a new version in July, and that's it for tomorrow. So we hope you can attend as well, and we can get your comments during the meeting. Or if you cannot attend, please join remotely, so you are up to date with what's happening here. Okay, thank you very much. And
I personally should welcome some feedback on the length of this meeting, because usually we have much shorter meetings with very well 10 minutes with per person, and we cut it. So we have a higher interest. People keep awake much better. But now we have longer discussions, which are with good results, I must say. But if people would be kind enough to at least tell me personally if they prefer the longer ones or the shorter ones, I will be very happy to receive those comments. Yeah.
my mailing list as well.
Yeah, also.
Okay. Thank you very much, and have a nice day.